Bismillahirrahmanirrahim. We will start exam view questions on chapter 1, Introduction to Physics, conceptual questions. Number 1. In the product A times B times C, A has 5 significant figures, B has 2 significant figures, and C has 3 significant figures. How many significant figures does the product have? You must know in multiplication and division the product have significant figure similar to the least significant figures. So we have the A has 5 significant figures, B has 2 significant figures, C has 3 significant figures. So the least significant figures we have 2. So the answer is letter A. Number 2. In the question B, A over B, C times C, A has 5 significant figures, B has 2 significant figures, C has 3 significant figures. How many significant figures does the quotient have? Also the same rule, the product or the quotient must have a significant figure similar to the lowest. So the lowest significant figures we have here is 2. So the answer is also 2. Same rule for multiplication and division. Let's move to number 3. In the sum A plus B plus C, A is accurate to 5 decimal places, B is accurate to 2 decimal places, and C is accurate to 3 decimal places. What is the correct number of decimal places in the summation? So put in your mind that in summation and in subtraction, the answer has decimal places similar to the lowest decimal places. So similar to the least accurate. So here the least accurate or the smaller number of decimal places 2. So the summation or the product or the summation has also 2 decimal places. So the right answer is A. The same rule in difference or subtraction. A minus B minus C is accurate to 5 decimal. B is accurate to 2 decimal. And C is accurate to 3 decimal. What is the correct number of decimal places in the difference? The least decimal places here is 2, least accurate 2. So the answer has 2 decimal places. So the answer is 2. Letter A. Let's move to real problems. How many significant figures are in the number? Hold on. Zeros on the left side we don't count. So we don't count these zeros. 0 on the right side and in between numbers we calculate it. So 0 here at the beginning we calculate it because we have decimal places here. Can you see the decimal places? Decimal place? So, and this 0 we calculated because it is between 2 numbers. So, how many significant figures are in this number? 1, 2, 3, 4, 5 significant figures. So, the answer is letter B. Let's move to number 6. How many significant figures are there in the number 0.010? As we said, 0 on the left side we don't count. We count this 0 because of decimal place. If there is no decimal point here, we don't count it. But we have decimal point here. So this one has 1, 2 significant figure. So the answer is 2. Letter C. Okay. Let's move to number 7. How many significant figures are in the number? Hold on. Now the zeros in between, so we will calculate them. Okay. This 0 in front of on the right side of decimal point. So we calculate it. So how many decimal places here? 1, 2, 3, 4, 5, 6. So we have significant figure. 6 or letter A. Number 8. The number of significant figures in this number. As you see, these zeros in between number, right? Between numbers. So we calculate it. So 1, 2, 3, 4, 5. So 5 significant figure. So we calculate or we consider zeros in betweens as significant figures. Okay, so we have here 5 significant figures. Letter C is the right answer. Number 9. The number of significant figure in this number. Don't forget, we don't calculate the zero on the left side, but we must calculate or put in our mind these zeros on the right side of a decimal place or a decimal point. So we have 1, 2, 3, 4, 4 SF, 4 significant figure. So the answer is letter C. Number 10. The number of significant figure in this number. Do you remember? We don't calculate this significant figure on the left side, but we consider these zeros, this zero because of the decimal point. So now we have two significant figures. So the right answer is letter B. Let's move to number 11. Which of the following has 4 significant figures? Which has 5 significant figures? Okay? Which has 4 significant figures. What about letter A? Letter A, zeros in between we calculated. So we have 1, 2, 3, 4 significant figure. 4 significant figure. Here, the zeros on the left side, we don't calculate it. Right? So, but we calculate this zero because it is on the right side in front of a decimal point. Let's see the decimal point again. Hey, the decimal, can you see the decimal point? So we have 1, 2, 3. This is 3 significant figure. We don't need it. So this is the one has 4 significant figure. Let's move to the next. Letter C. We have here 1, 2, 3, 4, and this zero calculated because it is on the right side and there is decimal point. So 1, 2, 3, 4, 5, 6. This is 6 significant figure. What about the last one? Must have 5 significant figures. We calculate the zero. We consider the zero because of the decimal point, right? So 1, 2, 3, 4, 5. So this is 5 significant figure. So the answer will be A and D. A has 4 significant figures. D has 5 significant figures. Number 12. In a parallel universe, the quantity, this is pi, has the value. This is the value expressed by in that universe 2. 4 significant figure. This is the first 1, 2, 3, 4 significant figure. We can't make round here, right? Because 4 less than 5. If the number less than 5, we cancel it. So the number will be 3.140. What about if you want 5 this significant figure? So 3.140. We round this 9, makes 4 is 5, right? So 1, 2, 3, 4, 5 significant figure. And the one up, letter A, 1, 2, 3, 4 significant figures. Let's move to the number 13. The metric system is preferred over the breach system. Why we prefer metric system over the breach system in science? For the following main reason. What is the reason? For we choosing metric system instead of breach system. Letter A, the metric system is more precise than the breach system. No, British system? No. All of them are precise, so this is wrong. Metric quantities can be defined more accurately than the quantities in the British system. All quantities, you can define them accurately, so this is wrong. Metric quantities are natural, where British quantities are invented. Wrong. The British quantities related to the feet and so this is wrong. Conversion between metric quantities are especially easy because they are related to factors 10. This is right. You know why? 1 meter equal 100 centimeter, 10 power 2 centimeter. 1 centimeter equal 10 millimeter. So converging is so easy in metric system. Let's go to number 14. When adding several quantities, the quantities can have any combination of units. Can you calculate kilogram plus Newton plus second? This is wrong. This is impossible. The quantities must have exactly the same unit, right? You can add 5 kilos plus 2 kilos plus 3 kilogram. All of this kilograms, so you can add them. So the quantities must have exactly the same unit. Letter B is right. The quantities must all be dimensionless. How? Dimensionless when you add only ratios, right? So the right answer is letter B. The quantities that you are adding must have same type of units. 15. When multiplying several quantities, the quantities can have any combination of units. Yes. When you multiply mass times acceleration to get the force, Newton's second law, mass in kilogram, acceleration meter per second square. So the unit for force kilogram meter per second square, that's what we call it Newton, right? So when you multiply or divide, you can use different combination of units, so letter A is right. When dividing several quantities, the quantities must have any combination. Yes, I'll give you example. Speed. Speed equal distance over time, right? Distance in meter times in seconds, so meter per second. So the quantities can have any combination of units. 17. When subtracting several quantities, when subtracting or adding several quantities, the quantities must have exactly the same type of units. When you add 2 hours plus 3 hours, you cannot add 5 kilograms of tomato plus them, right? So when adding or subtracting, the quantities must have exactly the same units. So the right answer is B. Let's go to number 18. A reasonable estimate for the mass of a typical female college student is, sure, it will not be 20 kilograms, right? 50 or 150 or 200, about 50. Something less, more than 50, 60 kilograms, 70 kilograms. So be reasonable, right? So the answer is letter B. A reasonable estimate, this is estimating, guys, for the height of an ordinary adult male, it's about 150 centimeter and 200, right? So it will be not 50 centimeter. Sure, not 50 centimeter or 70 centimeter. He's not in primary school. He is a adult. So it is about 200 centimeter, right? It's about 2 meter, not 3 meter. Sure. So the answer is letter C. This is estimating. A reasonable estimate for the mass of a typical newborn baby, it's about 3 point or 2 point. So 3 kilogram only. Letter B. not 20 kilogram, guys, baby, new human being. 21. A reasonable estimate for the height of the walls in an ordinary American house. It is consists from only one floor, so it's about 2.5 meter, not 0.5 less than the height of one person. And it is 2.5 meter because it is only one floor. Okay. Number 22. Reasonable estimate for the duration of typical physics lecture. The physics lecture. You divide each one by 60. If you divide 600 by 60, it gives you about 10 minutes. It's not enough. Sure, it's not enough. Here, divide 1000 by 60. It's 100 over 6. It's 1.40 over 6. 6 in 6 minutes. It's not enough also. Divide 3500 over 60. It is approximate 300, 500 over 60. It gives you about 58 minutes. It's a good time. About hour, right? Let's try letter D. Divided by 60, it's about 166 minutes, too much. So the answer is letter C. A reasonable estimate for the mass of ordinary passenger car. The car is about a ton. 1000 kilograms. So the answer is letter B. Let's complete the next questions in videos. I hope you got something from this video. Please follow this channel to get more about different problems. God bless you.